Besides density, another way of explaining why things float or sink in a fluid is through the buoyant force. Buoyant force is the upward force exerted on an object by a fluid. So whether it's a fluid like a gas, such as air, or a liquid, such as water, there is a buoyant force acting on the object. Let's look into a gas like air first. Let's say we have a balloon, a helium balloon. There are two forces acting on that helium balloon. There's the gravitational force, which is down, and the upward buoyant force. Now, if the buoyant force is greater than the gravitational force, such as when we first fill the balloon up, then the balloon will rise. However, over time what happens is that the gravitational force is going to exceed the buoyant force. So as time goes on, what happens is the gravitational force gets larger than the buoyant force, and then the object will sink. And so older helium balloons never seem to float in the air anymore. But what happens if they are equal to each other? And so to look at that, let's look at an example of when we are in the water. Let's say we have an ice cube in the water. There's again two forces acting on the ice cube, the upward buoyant force and the downward gravitational force. Now, most people know that an ice cube neither floats, or rises I should say, neither rises nor sinks in the water, instead it floats. And so in this tug of war, that's really what's going on. If the buoyant force is larger, it moves up in the direction of the larger force. If the gravitational force is larger, it moves down in the direction of the larger force. But if they're equal, it doesn't move up or down, and so the object floats. Now, I think we've all experienced in the water lifting up heavier objects that it seems like we can lift much heavier objects in the water than we can in the air. And the reason is because the water is helping us lift. It exerts that buoyant force. And this is why when we do physical therapy, a lot of times we might start in the water because it's less strain on our joints. So if we have a knee operation or a hip operation, we might start in the water until we work up enough strength to do the exercises in the air. Now, how do we calculate that buoyant force? Well, the buoyant force is equal to the gravitational force of the displaced fluid. But what does that mean? Let's say that we take a container and fill it to the very top with water. Then we put that container into a pan, an empty pan. Now we take our object and place it in the container of water, making the water overflow into the pan. If I take this overflowed water and put it on a balance, the buoyant force is equal to the weight, which is also called the gravitational force, of this much water. But another idea that we want to talk about is the volume. Another important concept. The volume of this displaced, which means to push out of the way, this displaced water, is equal to the volume of the object. And that's something that we'll exploit later on as we proceed. But what if the object is not completely submerged in the water? Then it's not equal to the volume of the object. Instead, it's only equal to the portion of the object underneath the water. So in this case, the volume of the displaced fluid is only equal to the volume of the object underneath the water. Now let's finish things up with some just note-taking ideas. Again, we said that buoyant force, any force is the letter F, B for buoyant. Units are newtons for any force, whether it be gravitational force, normal force, buoyant force. And the equation, again, is equal to the gravitational force of the displaced fluid. So it's again m times g, m for mass, g for gravitational field. However, this mass that we're talking about, again, is the mass of the displaced fluid. It's equal to the mass of the fluid that's been pushed out of the way, out of that container, into the pan.